Dear aspiring academics, welcome to the Academic Diaries, where we will talk about the different journeys people in different levels of academia take to become fully fledged professionals in their fields. My name is Itzel. I'm a third-year physics PhD student at the University of Virginia. As a beginner academic, I am curious about the paths people take to grow their careers. I hope that by asking questions to interesting people, we can learn more about all the options that we are, for now, blind to. So sit down, or walk, or wash your dishes, or maybe procrastinate that thesis you may be writing, and enjoy the chat. Today, we will talk to Dr. Olivier Pfister. He is a professor at the University of Virginia, specializing in atomic, molecular, and optical physics. Thank you, Professor Pfister, for coming to the podcast and sharing a little bit of your story with me.
My pleasure. Thank you for having me.
I want to go through your academic career ever since you got interested in physics, to your undergrad and then PhD, postdoc, and so on and so forth, up to you being a professor. So let's start at the beginning. Have you always been interested in physics?
I think somehow, somewhere, I thought it was cool, but I went through some phases of finding myself. I became certain as an undergrad, second year. So I think I now realize I forgot about it when puberty hit, but in 7th grade, we had a little monthly career fair and they had somebody talk about their job. And one guy came and he was a lab technician in a biolab with a passion for research and solving problems. And he spoke about that. And I thought, I like this. I was good in school, but I was too young. And then I forget all about it. Barely passed the baccalaureate exam in France, where I was born. And then don't know what I'm going to do. And so I go to medical school, which if I had to redo it again, now that I've done physics, I would be a doctor, like a physician. but I don't regret what I've done in physics.
What prevented you from being a doctor?
In France, medical school is brutal. As the first year, it's ranked. And if you're not ranked high enough, you become a dentist. And if you're not high enough to become a dentist, then you're kicked out after 2 years. And so I failed the first year. I passed as a dentist the second year, but I don't want to become a dentist. So I'm excluded from medical studies. It's a pretty harsh system. I don't know if they still have it. And then I decide, okay, I'm going to do English because I can speak English. And I go to the humanities campus in France after May 68.
Let's go through a little bit of history. And just recall, I'm summarizing this greatly since this is not the point of the podcast. But on May of 1968, in France, there were student protests, which escalated to clashes with police. The goal of the protest was not really achieved, but the impact to French society was great. And Professor Pfister will kind of outline some of the ways that university was impacted by this. If you want to learn more about this, you are one Google search away from a rabbit hole. You're welcome.
Then the student unrest, they build the new universities, like the campus of humanities is on east of town, the science is north of town, medical hospital is west of town, so that it's really, really far away, so that it's hard to organize any kind of student protest things. So I go all the way out to the humanities campus and they say, oh, well, it's 10 hours a week and awesome. I'm going to do nothing. It's going to be gorgeous. And then in September, on a Sunday evening at 10:30 p.m., the TV goes off because the TV program stopped in the evening at the time. It would not go 24/7. And so I watch until the end. The bubble comes up and pops and out comes, I'm going to get bored. It's like, screw that. I'm going to go to math and physics and see what happens because I'm not going to get bored. I don't know where it's going to take me, but this is the thing that's going to challenge me the most. So on Monday, I go to the science campus, north of town. I go to the registration office and said, can we still sign up for math physics first year? And the person said, yes, but hurry up because everything closes on Wednesday. I do the thing. And I started math physics, and it's, I live the student life, and sometimes I work, sometimes I don't. But I pass my first year, and then I'm going to the second year math physics. And then in E&M, there's the professor there, who's a researcher. And the professor looks at us and said, by the way, I don't memorize anything. I know the 4 Maxwell's equations, maybe charge conservation, and that's it. Everything else I can rederive. And I look at this guy and said, easy for real. I found my major. So that's when I knew, like, okay, I'm going to do physics. At the end of the day, after 4 years of college, I was the only one in Nice, in France, where I was a university student, the only physics major who graduated in June in 4 years. So we were 200 when we started, and there was one at the end.
That is amazing. I had a similar experience in university with people slowly leaving. We started with a class of 150, I believe, and just trickled away. I don't know how many of us were left in the end. However, I was not the only person left, so that is pretty amazing. How was your undergraduate experience in that university?
I had really, really good professors. They were all theoretical physicists. The third year, it was all theoretical physicists. I'm very, very grateful. So I visit those guys when I can see them, when I go back to France, because I have eternal gratitude for these people.
Professors can really have a huge impact on a student's experience. It is good to hear that you were impacted positively by them. Were there any classes that you really enjoyed more than others with these professors?
Oh, it was quantum. It was quantum. We had this guy, Jean-Marc Lévillon, who wrote the textbook called Quantics, Rudiments. He had in mind a series of 3. He wrote 1.5 with his co-author, Françoise Balibar. And they wrote a book together where he starts with dimensional analysis.
For those who do not know what dimensional analysis is, I suggest you look a little bit more into it after this podcast, but I'll give you a bit of a preview. If you have distance, like in meters, and some unit in seconds, and you want a velocity, you know that velocity is meters per second, so you can divide that distance by that time. It can help you greatly if you're trying to memorize equations, because you can just use their units. I hope I saved some people time that I wasted while I was doing the physics GRE, and for some reason I had no idea you could use this as a trick. You're welcome, and you are about to hear a very cool story on how you could just use dimensional analysis to get some cool results. Enjoy.
He's the guy who told us about Taylor's estimation of the energy of the Trinity test in the Manhattan Project, the first explosion of a nuclear bomb in a desert in New Mexico, featured in an Oppenheimer movie. The actual energy of the explosion was a military secret. About 20 kilotons, so about 1,000 semi-trailers full of TNT. It's about that. And there's this distinguished hydrodynamicist, Sir Taylor, and I think it's Taylor. I forgot his first name. And he wrote a couple papers in 1950 on the explosion of the Trinity, because there was information about that test that was in, Time and Life magazine. So they had published the initial photos of the explosion. So there's pictures where you had the timestamp in milliseconds, the scale on the picture, so you could tell how big the fireball grew, and that's all he had. And so he had a length, he had a time, he was looking for an energy, which is mass times length squared divided by time squared. And so he needed some mass. And using that, you make a dimensional analysis equation, and he plots that. And those plots line up, and it's on the order of 20,000 tons of TNT. Boom. Just dimensional analysis.
That is such amazing work. It must have been so great to have him as a professor. Just to get something like that from the quantities is crazy. I will admit, it was not until grad school that this whole dimensional analysis thing made sense. I knew that it kind of existed, but I never really used it. However, my favorite class will always be E&M, and that started because I watched this show called Einstein's Big Idea. It might be a movie. I don't know if I should call that a show. And they introduced Faraday's Law, and I just fell in love with the subject. I didn't even know any of the actual math that was going on. If anyone wants to watch one of the best documentaries ever, I highly recommend this Nova documentary called Einstein's Big Idea. It illuminates so much about science and how it's all interconnected, and I just love it.
I like E&M too.
It is the best class. But good classes aside, was there ever a class you did not like?
I guess I didn't vibe with StatMech that much. Rather than the class, though, there are moments that irked me. And now I realize these were important moments. I mean, it's important to write when you love it and dive into it. And when you hate it, that's also important. The worst is to not care. You got to do something else. The motivation, even if it's not an applied course, to know what it's good for, what question is answered. Maybe it was said to us, but I didn't hear it because I was not paying attention or too young or something, not mature enough. But StatMech is what happens when you try to do physics and there's too many particles, there's too many everything. You got to continue doing physics. So then there's like statistical methods. So that actually is interesting. And I didn't completely, when I was taught that, get the story. I wasn't connecting the dots and how is it useful to make a fridge or whatever. But the other thing that irked me was the density matrix in quantum. It was a little bit after undergrad. That was in grad, I think. Why on earth would we ever want to not have a quantum state when we're doing quantum and it's full of quantum states? Eventually, it's in quantum information that I realized that the mixtures of states, it's not a state. It's not a pure state. Therefore, it's not a state.
It's funny the things that we kind of get stuck on while we're learning. And I guess it all makes sense now to you because, I mean, you do a lot of quantum computing and mixed states are big there. But I like that you mentioned wanting to know the motivation of things when you're learning them. I think that's very important. Sometimes it's harder to find your own motivation to study the subject if you don't know why you're studying the subject. You can't help but wonder, like, why am I doing this very hard thing? Like, where is it going to take me? I feel especially when you're starting in a field, it's hard to see how profound things you learn can be because you're stuck in that beginning loop of this is hard. What am I doing? Returning to your career again, when did you know you wanted to be a PhD student?
Out of my undergrad, I was going around talking to my professors because, I was in a smaller university and I wanted to go to Paris to grad school to be in a good lab and learn something, do something exciting. And I wanted to do lasers and quantum mechanics. And that was my conclusion in my undergrad. I was going around talking to my professors, I want to do lasers and quantum mechanics. And well, to this day, I'm still doing that. It was a little bit vague in terms of career prospects, but I wanted to do a PhD thesis. So one of my professors recommended me to a guy in Paris. And so I had to do an extra year of master's because it was 4-year university degrees. They've changed that system since, but 1-year master's. And so I did my master's in Paris. I had to do my military service out of undergrad first. It's called scientific military service or something. Now they've stopped doing the military service in France. I think it's kind of too bad because it connects society together because you get to meet people from different social origins and realize that students are maybe 5% of the total population at your age. And there's a lot of people who haven't done advanced university studies, and that doesn't mean they're dumb. So your worldview changes a little bit for the better, I think, because you're exposed to other people with different viewpoints, different lives. So I did my military service in an artillery regiment. And it was nice because it was a maneuver regiment. So they have like targets of old tanks that are there at the bottom of the valley, and that's the enemy, and you gotta drop some shells on them, and there's some cannons that are hidden behind a mountain, and you shoot over the mountain. So every week we would go do 1 or 2 maneuvers the whole year. So that year was actually pretty good because instead of staying in barracks doing nothing and being bored to death, which was pretty much a lot of the military service was that, except for 1-month maneuvers, we had like 12-month maneuvers. So I did that for 12 months. Then I remember I can't compute derivatives anymore. But no, it was fine. And that increased my motivation for going back to grad school, actually.
I always say people should take a little break sometimes, either before undergrad or after.
Yeah, I agree. Let the dust settle a little bit.
Yeah. And I think you're too young in undergrad. And that year kind of gives you perspective.
Did you take a break?
I did. I took a break before grad school.
Okay.
A year.
What did you do?
I worked, I tutored a lot, and then I traveled and I went all over Europe for a month and a half with my brother. And it's the best thing I'd ever done. I'm very lucky that I was able to do that, obviously, but it was a great time. I look at the pictures now and I'm like, wow, I can't believe it. We were like sleeping in trains going from like one place to the other overnight. We were in like Milan in the morning and then Venice at night. It was great. It also helped me decide that I did want to do physics. I was like, this is definitely my thing.
I'm a big fan of doing nothing also when you take a break. It's just like, I'm going to be empty looking at the sky for now. And it's going to, maybe it stays 5 seconds like that. Or maybe I'll read a book for an hour or whatever,
I've started doing that now more than I did before. I used to be like, I have to be doing something. But now over the weekends, I'm like, I can do whatever I want. And that could be nothing, or it could be knitting or reading. And I kind of just let myself roam around and do whatever I want to do. And that's great. And then on Monday, I'm like, ooh, I can get back to work. And I feel super good. But enough about doing nothing. What was your PhD like?
The science was fantastic because I was working with this group that was doing laser spectroscopy of molecules. But the challenge was to see absorption lines, to have them as narrow as possible, to have very, very high resolution. And to do that, there's a lot of physical effects that conspire into broadening the line shape of the absorption of molecules. So the Doppler effect, the collisions, laser power broadening as well, to name a few. And so they had this gigantic gas cell that was a steel cylinder, 18 meters long, 70 centimeter diameter. It's like a ginormous thing.
For those who are really into the imperial system, he means 262 feet long and 2 feet in diameter. So pretty massive.
And the laser was going in there and doing 3 round trips, and the pressure in there was down to, 10⁻⁶ millibars. Very, very small pressures. And we could resolve the hyperfine structure all the way to like everything that was available. I learned a ton of stuff about stabilizing lasers with servo loops, doing plumbing on vacuum chambers. Like there was an engineer with the team, a research engineer. He was a great guy. And he was saying, well, for an experiment to work, you have to have 3 things. You have to have power, you have to have water, and you have to have gas. And those 3 things are it's like utilities, right?
Yeah, that is so right. The first thing I learned about when I joined the lab was the vacuum, which we had to tear apart and rebuild. And then I did plumbing. So I am 2 out of 3 for all the utilities. For anyone confused, I do not mean the vacuum that cleans the floor. I mean a steel chamber from which we have removed all air and gases. So they're essentially like the vacuum of space. Very cool stuff. Takes a while to achieve.
The experiment that is beautiful, it's going to work all the time for 50 years. It's like, well, you might have to take it all apart because you never know where research is going to go. But you do want to make it well enough that it's reliable. And maybe you can reuse it a little bit. But if you spend too much time optimizing everything, that's actually wasting time. So we always live in that gray area of optimization.
Yeah. I had to kind of get used to that. I'm currently building a chip for the lab. And the corners are never going to be sharp. I guess we've accepted that by now. But I think for a week I was like maniacally going to the lab and being like, I need this to be perfect.
But it's good to try. And nobody's going to tell you because we're doing prototypes, right? So we're doing things. And sometimes there's somebody somewhere who knows how to do it 10 times better than me. And I should really go talk to them. But sometimes nobody's tried.
That's something I really like about being in the lab. Okay, I can build it, and maybe I could build it better than the engineer. Who knows? Or sometimes you just have to ask.
It's always good to ask. There's a guy, when I was a postdoc at GILA, who used to say, remember, 6 months in the lab can always spare you 3 days in the library. I kind of adapted it to my teaching. 3 hours getting stuck on homework can spare you 10 minutes talking with me.
That's funny, and that is very true as well. I mentioned this on I think every podcast I've had so far. Office hours are very important. It should be just as important as going to lecture, and going to them really changes things. I could go on and on about how important office hours are, so I'm going to stop myself here and ask you. You did a postdoc. Did you do that in the US?
So I did 2 postdocs. After my PhD, I went to GILA at the University of Colorado Boulder to work with Jan Hall on whatever Jan Hall wanted me to work on, which turned out to be a few different things. But generally, this ultra-high resolution spectroscopy, and he was very gracious. Also was lucky to get a grant from the French government. But I did 3 years with Jan. That's when I got started in quantum optics. It was a riot because he talks about things that are cool and you go play in the lab. Working with Jan was fantastic. I was really lucky. And then I got to work at Duke for 2 years with a guy called Dan Gauthier, who was up for tenure when I arrived. Now he's full-time with a startup he co-founded that does drones and reservoir computing and kind of crazy stuff. But Dan was really, to me, a renaissance man. He was doing AMO physics at the same time, and the other half of his group was doing heartbeat synchronization in frogs. They discovered that in frog hearts, when the heart fibrillates, you can just drive it, but not with a giant pulse, with a small voltage pulse, but a periodic one. And the heart just comes back. And they tried to do that on the sheep heart. And it didn't work because the sheep heart is too big. And there's plenty of spatial effects. The big mammal heart like ours and the sheep and the pig and whatever are more complicated than the frog heart. I worked on making a 2-volt laser out of potassium atoms. We got the laser working after a couple of years, a year and a half, so perfect for me to get a PRL.
A PRL, for those who may want to know, means that he published in the Physical Review Letters, which is the most prestigious physics journal. So it's a pretty cool achievement.
I won the green card in the lottery of the Department of State, and after 3 years of postdocs, and then I decided, okay, I'm gonna look for jobs in the US. And then I started getting interviews the first interview I got was University of Rochester. You give a 1-hour talk, you meet 12 professors, and it was so much fun. But then I was totally unprepared. Like the department chair gets me in his office, said, okay, so how much do you need? How much do I need? The guy then realizes I'm absolutely a little bit too clueless. And then Nick Bigelow gets me, he was my host, and said, oh no, you can ask for $200K. It's called startup money. And nobody told me. So that didn't work out. They could see I was a little bit young. Then I realized it's a completely different job here in the US where they expect you to start your own thing. And they hire you because they don't have that in the department and they want it. In France, it's like you're going to work under Professor so-and-so to do that. If you're a good boy, when you get a little bit older, you get to do your own thing. But it's a waste of your youth. I think ideas don't. I still have ideas and I'm not young. But you have energy. It's like you go after money. And that's what you need to start something from scratch, from the ground up. So yeah, the US for me was the American dream to get a job here.
Wow, that's amazing. Did you ever consider not doing academia when you were looking for jobs?
I had an interview at a company in Boston. They would have hired me, apparently. They wanted to hire me, but they were doing plasma physics, and I knew not the first thing about plasma physics. And it didn't seem to concern them. Apparently, they got started during Star Wars, but the strategy is to write SBIR proposals. And you're supposed to pop one a month. And if you pop 12 a year, one of them might work and it pays your salary. And then the next one that you get, then you can actually use the money for some research. All the employees in the company were doing that, especially the young ones. But it was very little about the scientific endeavor, the thrill of discovery, and it's a business.
What made you choose becoming a professor over that job?
I wanted to give it a try. There's a little bit of anxiety linked to that, especially when you're a grad student or a postdoc and your career depends on, and even junior professors, when your career depends on research results, so you don't know if you're going to get a result. You could get a -1. You can always get a good negative result. And negative results are important. Like I did the experiment. These are the error bars. It's a very good experiment. This is what I looked for. I didn't see it. We can therefore say that it's not there to that precision, to that confidence level. Well, they don't give you the Nobel Prize for that, but it's a result. And it's not valued enough because it's part of research and it's important because we learned something we didn't know. Therefore, that was research.
It's kind of like an analogy to life. You don't know what the heck is going to happen. You just kind of do it. And then, ooh, bad thing happened. Probably shouldn't do that again. Oh, good thing happened, maybe go in that direction. I think that's something that I was not told or maybe taught that much. I think in undergrad sometimes because we do experiments that are already done, there's always an outcome that's quote unquote positive. And so we kind of miss on the fact that no is also a really good result because it means don't go in that direction. And when I started doing research, I realized there is no light at the end of the tunnel.
Not sure if there's a tunnel here.
Yeah, and I think like exploring it and being like, okay, now I'm gonna like change gears. Clearly not a tunnel, now a mountain. Let me put like mountain clothes and just try to climb that up and see what happens.
And I think you're alluding to something which I think is important, that you get empowered by the scientific approach and the method. I always compare it to navigating. Like, you have a sailboat, it's great. And it's like that person does never want to lose track of the coast side. Then you're not going to discover anything, right? But then you have a sextant, you have a compass, you know how to look at the stars, you know what they mean, but you can be in open sea and not be lost. And I think that's what the good researchers are, because I'm trying to discover something, but I'm not lost. It's not, oh, I went to MIT and therefore I discovered. No. You went to MIT and yeah, there was lots of interesting research to do. And of course, highly likely to lead results with lots of good resources. And that empowers even more, like a boat that's really big and really fast and cover more ground and go through storms.
Losing that fear is a very long process. And I think I'm kind of like going through it in this PhD. But enough about navigation. How were your first few years at UVA?
The beginning was fun because like you get to build your thing. There was a good scientific community and mentorship, and so it was a lot of work, but you felt supported. People, I mean, you're going to have tenure. So if your experiments don't work, you're going to have a problem. If you don't get funding, you're going to have a problem. If you teach poorly, you're going to have a problem. Less of a problem than if you don't get funding, but you know, it's like research. You do what you have to do here now, and then the next step will come and make a decision. We studied quantum optics, and I got a PRL with a nice twin beam experiment that was super stable. And teaching was good because the undergrads at UVA are generally awesome. They are a pleasure to teach. The grad students are, a lot of them, it's more a mixed bag sometimes, but there's a lot of them who are really top notch. And I've had people who were probably more clever than I was.
I'm really glad that you have had a good experience with the faculty as well as your students and other students here. It is really good to be in a place where you feel content with the people surrounding you as well as the place itself. As a person that has guided many students, what is some advice you would give to someone who may be listening to this right now?
So I don't know how my particular trajectory is a reference of anything. I feel I've been very, very lucky, but I was lucky to, at some point, decide when I was a student, oh, I want to do lasers and quantum mechanics, right? And stick to that because I've learned a ton of stuff, and that's really what makes me happy. I'm say the platitudes are follow your dreams, be yourself. For research, it's really important because we're sort of like, we're relying on ideas, right? So there's a creativity aspect to it. Well, who else relies on creativity in their job? Well, artists, right? There's technique too, because then you have to be able to paint well or sing well. But if you don't have anything to say, technique is, okay. You can do calligraphy on somebody else's writings. For research, it's really that. I think sometimes I've met colleagues who are not. I'm into problem solving and creativity and accepting there's a risk that it's difficult. We're not guaranteed to find a solution. I did a course where it was problem solving. It was an engagement course, so for like non-majors, first year students, undergrads. It was called Embracing the Question Mark. It's all puzzles. The point is to get stuck. It's really important to have that. The best people I know are the guys who got Nobel Prizes, and they're not. This was the thing that would give me my Nobel Prize, and I went after it, right? They're super curious about stuff all the time. Right? It's so easy to lose that when you're under pressure because you have to get tenure, you have to get grants, you have to get good teaching evaluations, you get whatever constraints in your job. It's really important to get anchored in that certainty that this is what I love.
I had not thought of things like that, but you're right. Life is kind of like a puzzle where you're trying to figure things out as you go, and whether there's a solution is kind of unclear. But if you're not curious about the possibilities, then you do not ever get close to solving it. And I guess passion for the things that you do also kind of foster that curiosity. In the line of things that you are passionate about, what is your favorite thing about being a professor?
Right now it's pretty good. On the research, yeah, I really like the moments with the students and the postdocs and whoever I work with. It's sort of a communion where everybody is on the same wavelength and we're all trying to understand something. And there's this effort and everybody's doing the best and it goes back and forth. These are the moments where you can change the world because people brainstorm together. In a good balanced group, it's better because people can contribute. People grow into badass researchers and take me to school on things that, well, yeah, it stings a little bit, but I'm actually proud of you.
That is so sweet. I guess it's really nice to watch your students mature. And I agree. I think having like people to bounce ideas with and work with people to tackle problems together is pretty great. And it's a very nice bonding experience to balance things out with something that you don't like about being a professor.
Being a professor in the US has been pretty awesome so far because you're given the means to start your own group, to really have academic freedom. This means something. What don't I like? I guess sometimes there's a bureaucratic inertia of the system, right? And sometimes you're in meetings where people talk and talk and talk and okay, I talk and talk and talk too, but nothing really gets done. Having co-founded a startup and talked to other people in the business world where, they're not going to spend too much time understanding a problem like academics tend to do. I've been really lucky and privileged to do what I've done. So if you ask my wife, she's going to tell you a completely different story. So I'm so hypocritical right now. But really, what's awesome about being a professor in the US is I don't have to care. I can just do my thing.
That is true. You can kind of do what you want to do to a certain extent. And it's really good to hear that you really enjoy being a professor since, like you said, loving what you do really helps you push forward even when you have some things that you don't like. But it makes sense that bureaucracy can get annoying. It must be also interesting to see the differences between what the business world and academia are. Now we have reached the end of my questions. Thank you so much for coming here and chatting with me. It was very, very fun to talk to you.
You're very welcome. Thank you for the opportunity. It was a lot of fun.
So there you have it. Another episode of the Academic Diaries. I hope you enjoyed my conversation with Professor Pfister. If you have any questions, please leave them in the comments. And do not forget to follow the podcast to see who the next professor will be. If you want to learn more about Professor Pfister, please check the link in the description. Thank you for taking the time to listen, and I will see you next time.
Thank you for making it this far. Although maybe you're doing the dishes and you can't really skip me. So in that case, hope you like bloopers as much as I do.
Bleep, 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 bleep. Here the computer's mostly quiet. That was me trying to find a motherfucker. Dimensional analysis. Dimensional.